Well, g'day, Max here again, welcome back to the shop. Well, winter's moved in, well and truly here into Perth. I don't know how you guys get on in the northern hemisphere, but it's bloody cold here, we're not used to it. It's put a bit of a dampener on my driveway progress to the new shop, 'cause it's been too cold and wet to go and do anything, so hopefully I'll catch up with that during the week and maybe next weekend. So this episode we're going to try and finish up the Toolpost grinder. So I'll get the motor reassembled, the spindle reassembled and see how we go. Hopefully it'll all come together easily, but you never know, there's always dramas. Something will happen. We'll have a go. Okay, we're just going to touch up our brushes. There is a very slight angle worn on them, and because we've touched up the commutator, just give this surface a bit of a touch up so the diameters match. Now what I've done, I've just got a parallel mounted in the tool post and another piece of tool steel clamped in to hold the brush square. So the first thing is we get the brush on centre, the centre of the brush on centre height, which I've just matched up to the tailstock. So I've just very lightly scratched a line on it, very faint, rotated it, done the same, had a look and split the difference. So the centre of our brush is on centre. So what we do now is we mount the armature up, and we also square up and bring you down. We square up our parallel with the chuck. So we have our tool steel clamped in position. So we just use the face of the chuck to square all this up. Which is there. Knocking everything around there. Okay, so our guide bar will hold the brush at 90 degrees to the axis of the lathe. So we'll put our armature in. Okay, I'll bring you across. So all we do now is we hold the brush in position here, up against the commutator. We'll put a piece of wet and dry against the commutator, and that will just square up the brush. Okay, so this is where you need 3 hands. We put our piece of wet and dry around the commutator, bring up our support. I think wherever I go, I'm going to have something in the way of the camera. till we see the full face of carbon touching on the emery. They don't take much. And that's that one all nice and... Oh, where are we? Where are we? There you are. That's that one all nicely squared up. Okay, so the second brush, we'll get that squared up the same way. Don't drop them. Still got a little shiny spot in the corner that hasn't cleaned up, so I'll keep going. Okay, let's clean that one up, all nice and square now. So these are ready to be fitted back into the motor when the armature goes back in. Okay, so it's time to push our bearings on the armature. So we have our new bearings, so they'll slip over, and we'll use just a piece of aluminium scrap I got out of the bin. I've just faced off one side so it's square. Now just note one thing, if you are pushing bearings on, if I hold the bearing against the thing I'm pushing, because you have to push on the inner race of the bearing, you'll damage the bearing pressing on the outer race. So if I hold that with thumb pressure up against my tool, I should be able to freely rotate the outer race. That tells me there's no pressure being put on the outer race when we're pressing all the forces on the inner race, which is what we want. So we slip our bearing on, slip our little press tool on. We'll just put a spacer in here. Just come down with the screw, nice and gentle. Now we just eyeball this, put a little bit of weight on. Visually eyeball it to make sure it all looks square. We can still turn our outer race while we're pressing. That's it, she's home. One bearing done. We'll just repeat for the other end. And get it out the box. Same again, make sure our armature looks visually square. It only takes gentle pressure. That's it, we're there. So we can carry on and fit this back into the motor casing. Well, okay, time for reassembly. We'll put our housing end on first. That feels good. Gently slip the armature in. Well, that sounds a lot better already. Get our four screws in. Give them a gentle nip. Make sure the armature's still free. Bit of gentle tension on the screws. Oh, that feels very good. Excellent. So we have a cover to go on the other side here. Now this cover has all this gauze mesh in it, so I'm guessing it's probably just like a filter. Stop it sucking the crap into the motor. So I'll just give this a bit of a quick blowout with the airline and we'll get that fitted on. Okay, so we've got our gauze filters cleaned up. Now they just slip down inside the cover. Cover lined up. Everything's still spinning nice and free. We'll slip our brushes in. This brush is a bit noisy, so I'll just turn it around 180 degrees and try that. That's better. I'll try it with this one. No, that's okay. Put our pulley has to go on next. Just making sure we line up the flat on the shaft with the grub screw. It's in. In with the grub screw. Okay. Now we'll get a cord, we'll power it up and see how she goes. Okay, moment of truth. That seems alright. There's a little bit of run out in this pulley. Because if you get any run out, you'll get a bit of vibration through your grinding, so we might see what we can do about this pulley. Okay, let's check out this vibration we were getting. So we're just going to clock up this pulley. So on the larger journal of the pulley, we're getting 3 thou run out. On the smaller one, we're getting 5.5 thou run out. So we've got to reduce that. Now I've tried putting the pulley in a different location on the shaft and it's made no difference. So now we can't pull the armature back out and remachine this pulley because we've got nothing to grip on the other end. And we can't push an arbor through the centre of the pulley and put it in the lathe because that'll give us, I don't think that will achieve anything. We've got to have this pulley running dead true to this shaft. So the only way around that is to machine the pulley in situ on the motor. So we'll see what we can't come up with to achieve that. You've got to get all the vibration you can out of these things because it all transmits back through your compound and your cross slide when you're tool post grinding on a lathe. So the more we can get out, the better. So we'll see if we can't rig something up just to true these pulleys in situ. Well, this segment should be called Adapt and Overcome. we've had to come up with this strange setup here. As we were saying before, our pulley has to be machined on the armature of the motor, and we can't grip that in the lathe to machine the pulley. So what we're going to do, we've come up with this strange setup. So we've got our tool post secured to the Bridgeport mill table, and I've got another lathe. It's a 9-inch Hercus Australian made lathe, which I've had the saddle off it for a long time now because I use it for a little bit of wood turning. So I've clamped the saddle down to the mill table, and we've used the compound to set the angle for the pulley. Now these are a crowned pulley, so it has a taper machined up either side of it, up to the centre. So the centre is a bigger diameter than the outsides, and that's to keep the belt tracking in the middle. So we can only clock off a small distance, so we can only clock up half of the length of the pulley. So we've got our indicator set up, and we've just tapped around the compound slide until we get it halfway up the pulley, and we're about within half a thou, which is plenty close enough for this. So we can set up now, we can put a tool in now, and we can machine the first half of that pulley, the small step. Then we'll have to reset for the larger pulley, because as the pulleys change in diameter, I think the crown angle changes, but I'll read. It is reading a different angle than this smaller diameter, so I'm assuming that's the case. So we'll get a tool set up, and we'll take a very light skim across the first small step. Okay, we've got a tool set up in place now. We just pinched the old lantern tool post off my south bend. So we'll just mark this up with a blue Sharpie so we can see a bit better. Take a little cut. Now this is the high spot. Just a fraction more, I think. I might give it a little squirt of WD-40 for its last cut. Okay, well, that looks good. Okay, so I'll set up now to do the other angle. That's reduced that vibration quite a lot just doing that half of the pulley. So hopefully by the time we do the whole pulley, we're down to very small amount, if nothing. So let's set the tool up for the other half of the pulley, then we'll move on to the big pulley. Right. So break that sharp edge with a file. Well, okay, I'm happy with that. We've greatly reduced our vibration by taking the run out of the pulley. So I've had a wind machining both sections. So I guess now we'll break the setup down and we'll move on to the spindle bearings. Well, I was hoping to get this all knocked off, but it took a bit longer than what I expected because of the pulley issues that we had, having to machine that. So we'll have to continue this one, the tail end of this, on next week. So our progress on our profile turning attachment for the lathe. I've got my ideas pretty well planned out how we're going to proceed with that, the design. So I've started collecting a few materials, keeping my eyes open for bits and pieces. So hopefully we'll get a start on that in the next couple of weeks. And, we'll see how we go. So thanks for watching. Stay tuned.